Welcome back, friends, and thanks for watching my previous video. And you everyone gave the good response of my previous tutorial. So now, in my previous lecture, we discussed about the direct ELISA. In that ELISA, we discussed that was the initial step of ELISA. The people, the scientists or the designers was only designing the ELISA. That was the basic step of ELISA. Now, there was some problem with that ELISA. In my previous lecture, I told that I will discuss about what was the problem with that ELISA, direct ELISA. Now I'm just going to tell about what was the problem with the direct ELISA, why we are not using that ELISA. So the first problem is that the problem was that sometimes the enzyme linked antibody was not going to bind on its specific antigen. Sometimes if that enzyme linked antibody is not going to make a bond with antigen, specific antigens, then again the color will not produce. If the color is not produced, then you cannot see the result. And you will think that the patient have no B antigen. But actually the B antigen is present. So less immunogenic reaction fails this test. And second problem was that only one antibody was going to make a bond with antigen, so very less color intensity will produce. If very less color intensity will produce, the detector, this intensity, the color, what the color would be produced, intensity of that color will be read by the ELISA machine. Sometimes if the color intensity of a product will be very less, so what would happen? Sometimes machine cannot sense that intensity of a light. So again it will respond a negative result. Then you will think that you have no B antigen, but actually B antigen is present. Now, because of that problem, now just we are going to modify in this direct ELISA. Again, we have taken a polystyrene plate. This is the polystyrene plate, and here's my patient. I have taken serum sample. Now I will put my serum sample in this polystyrene plate. So every antigen those are present in this serum that will go and make a bond with polystyrene. They have affinity, they love to bind on polystyrene, that's why they will bind on polystyrene. Here in the serum there is a 3 antigen present, that is the A, B, C, and that is those antigen will bind on polystyrene plate. Again, I will use the blocking reagent. I will use the blocking reagent because every vacant area, every free area will be blocked by the blocking reagent. And when you will put the antibody, the antibody will not bind on C, will not bind on A only, that is the specific, that's why it will bind on antigen B. It will not bind to antigen A, antigen C. It will bind only on antigen B. And if I will not use the blocking reagent, it may be this antibody can go and bind the vacant area of a polystyrene plate. So to protect that things, we will use the blocking reagents. Now, I have taken the blocking reagent here. Now I'm just going to use a primary antibody because I have a task that I would have to detect the B antigen is present or not in the sample. That's why what would happen? To detect B antigen, I will use the primary antibody, that is a specific antibody that will bind only on antigen B, not on antigen A, not on antigen C. But this antibody what I have used here, that is not enzyme linked. This is the primary antibody. So what I have used here, this is the primary antibody. This primary antibody will not have a particular enzyme. That that has not ability to convert the colorless substrate into colorful substrate. Now, what will happen next? This primary antibody, I will take this primary antibody and I will insert in a mice. When I will take this, again think that, I will take this primary antibody and I will insert in mice. This is the immune headquarter of mice. When I will insert this primary antibody in mice, the immune headquarter of mice will generate 3 different type of antibody. Because if I will insert this primary antibody, then this primary antibody have 3 epitope. One is here, one is here, one is here. One antibody have 3 epitope. Epitope is that because this primary antibody, when I will insert in the mice, this antibody will be foreign for the mice, and if that is the foreign particle, then to kill that foreign particle, to neutralize that foreign particle, the immune headquarter of mice will make 3 other antibody. Why that is making 3 other antibody? Because one antibody, if it will go in mice, it has 3 epitope. It means 3 variable region. This is one variable region, this is another variable region, and that is the last variable region. For these 3 variable region, the mice headquarter will generate 3 antibody, and one antibody will bind on that portion, second on that portion, and third on that portion. Now, what antibody the mice is generating, that is making to neutralize this primary antibody, that antibody will be called secondary antibody. It means that we have a first, that is the primary antibody, and we have a secondary antibody like that. And that secondary antibody produced because it has 3 variable domain. So this red color is secondary antibody. Secondary antibody. Now, look at here. I have taken a primary antibody. This is the specific antibody that will bind only B antigen. Now, this primary antibody will be inserted in a mice. When the mice, this primary antibody will go in mice, it will work like antigen. To neutralize that antigen, the immune system of mice will generate 3 different type of antibody. That antibody will bind on this primary antibody, and that secondary antibody is enzyme linked. This is enzyme linked. Okay. If here, look at scenario. If I will give this substrate, this is substrate, this is substrate, this is substrate. Now this antibody will convert, and this secondary antibody is enzyme linked. So this enzyme will convert this substrate, colorless substrate, to colorful substrate, colorless substrate to colorful substrate, colorless substrate to colorful substrate. Look at here. Here the intensity of light is here, here, and here. It means that if you are thinking that, if you talk about the intensity of light, then you can see that here the lot of intensity of light. It means that the ELISA machine will detect very soonly. If you will comparison with direct ELISA, with that ELISA, then you will find here the color intensity was very less, but here the color intensity is very high. Here the enzyme linked antibody has not directly binded with antigen. There is a mediator, there is a primary antibody between antigen and secondary antibody. It means that the enzyme linked secondary antibody has not direct contact with primary with antigen. That's why this type of ELISA is known as indirect ELISA. This is the indirect ELISA. We move from direct to indirect. We modify to direct into indirect. It means we increases the intensity. It means if you are moving to direct ELISA toward the indirect ELISA, then you have increased the sensitivity. It means conversion of direct ELISA into indirect ELISA, that is a sensitivity. Secondary, that is the indirect ELISA is more sensitive compared to direct ELISA. So this type of ELISA is indirect ELISA. Now, just I'm going to clarify everything what I have done here. So just I'm moving everything. So again, you will tell me now it's your test. So this is our polystyrene plate, and we have put serum sample, and in serum sample there was A antigen, B antigen and C antigen that has affinity with the polystyrene plate here. Now I will use the blocking reagent. This is our blocking reagent. I will block the every free area of a polystyrene plate. Now I will use, because I want to detect a B antigen, that's why I will use first of all primary antibody. Now after that, this primary antibody is not enzyme linked, but that has affinity to make a bond with B antigen, not with A antigen, not with C antigen. Because I have this generated a secondary antibody. How I have generated? First of all, I will inject this primary antibody in mice, and the immune headquarter of a mice will make 3 different antibody, and that antibody is known as secondary antibody. This secondary antibody is enzyme linked. If this enzyme linked, I will use the colorless substrate. Here is a colorless substrate, and that colorless substrate is going to be converted into the colorful product. Here, if colorful product, you will pay attention here, then you will find more color intensity. It means that you have increased the intensity in indirect ELISA. This is called indirect because here the enzyme linked antibody not directly bind with antigen, that is indirectly has bind on antigen, that's why it is known as indirect ELISA. One thing more, if you want to check that there is anti-B antibody or not, suppose that I'm a patient and I want to check that in my blood there is anti-B antibody or not. So what will happen? Again, I will take polystyrene plate. Now if you want to check that the primary, that is the antibody B is present or not in my sample, in my blood, then take my blood, and after taking, you will take a polystyrene plate, and taking polystyrene plate, this polystyrene is already, it has already B antigen, and that type polystyrene plate is known as pre-coated polystyrene plate. Because I want to check only a specific type of antibody, and that is anti-B antibody. I want to know that in my blood there is anti-B antibody or not. I want to know only that things. So I take a polystyrene plate, and that is already pre-coated antigen. Now I will use my serum. You take my serum and you will put my serum here. So what would happen? The enzyme, this is the primary antibody. This is the antibody. I will not say the primary antibody. I will say only that if there is a B antigen present in my blood, then to neutralize my antigen, my immune headquarter may have designed antibody B. This antibody B will bind on only B antigen. I will wash it. If I will wash, then what would happen? Other antibody except to B antibody, that will remove away, that will wash away. Now I will, because I know that what is the structure of our antibody, so I will use a secondary antibody, and secondary antibody will make a bond with primary antibody, and this is enzyme linked. this is enzyme linked. On washing, this is enzyme linked. So this enzyme linked secondary antibody will convert, when I will use substrate, then it will convert into product. Again here product, again here, that will convert into, this is substrate and that is product, this is substrate and that is product. Now again we will see the high intensity of light. So this is the indirect ELISA, because you can see that here the secondary antibody enzyme link that has not attached with directly with antigen, that's why it is known as indirect ELISA. But indirect ELISA is not going to also in too much use. Reason, there is some problem with again it. The problem is that if suppose that you have in your serum there is a 3 type of antigen, that is B, that is I, that is L. This type of antigen is available. What would happen if you will use the primary antibody to detect this antigen for this portion, for this portion, for this portion? I think that the first portion, that is the upper portion, is same of each antigen. So antibody will not discriminate. It has enabled to discriminate for upper area. If you are using the antibody B to detect antigen B, that antibody can bind here, that antibody can bind here, that antibody can bind here. It means that if you have no antigen B, then that antibody will bind to I, that can bind to L, and you will use secondary antibody, then it will bind on primary antibody, because on washing that will not wash away. Why that will not wash away? Because it has affinity for the antigen. So here again you are not going to find a clear test. So here this secondary antibody will be this indirect ELISA will fail. So now to protect from that things, to want to overcome from that things, we will discuss in my next video, that is the sandwich ELISA. Okay, so that was indirect ELISA. I hope that you have understand well. Thank you very much.